This is for Year 12 methods. It comes out of the Technology Refresher Masterclass. Question number 9. I can't see the graph. What do I do? Okay. These are the two-step process that I use all the time when graphing things to try and find them. 1, do a domain. So minimum X, maximum X. Then 2, do a zoom auto. And what a zoom auto does is it keeps the domain the same, but changes the Y value so that the graph fits. So that's what I'm going to do all the time. I need to think about a domain. So the size of the population of geese is determined by this rule, where P is the population, T is years. So straight away, it's years. So my minimum X that I'm going to use is 0. And since I've been asked about 10 years, I might do a maximum of 20. I could do 10, but probably the question's going to ask me after 10 years, what's 50,000? So I imagine 10 will be less than 50,000. But anyway, we'll see. Okay, so I go over into my equation and I'm going to put 4300, bring up my keyboard, math 1, e to the power of, I've got a fraction, so I'm going to use x on 10, and I'm going to need to make sure I get out of my power and do minus 300. And then I press xe just to make sure that it's exactly what I want. 4,300 e to the x on 10 minus 300, that's very good. So I open up a window and I want to change my x value. So I'm going to go from 0 to 20. Just change the x's. Pick this up, drag and drop. As I suspect, I can't see it. So I go zoom auto. It will automatically change the y values. And there's my graph from 0 to 20. So I want to have a little look at these numbers. The minimum y is 4,000 and the maximum is 31,000. So I might make that 0 so I can see the bottom, and I might make that 50,000. So I've used the y values to give me a guide, and look at that, exactly what I'd like to see. So find the size when t is 0, when t is 100. So I might come up here and do that in main. So keyboard, math 3, given x equals 0. The population is that, and when x is 10, the population is that, and to the nearest geese, that should be, to the nearest goose, 11389. So 11389 geese, and 0 was 4,000 geese. After how many years will the population pass 50,000? I could do that using my graph. I could put on 50,000 and I could go drag and drop. Also, I need to either just move my graph across and go analysis G-solve intersection to find that it's at x equals or t equals 2459, which means these are in years after how many years? So when t equals 24, it's not yet 50,000. When t equals 25, it is 50,000 or more. Therefore, I'm wanting 25 years. How else could I do that? I could come up here and make this equal to this value and go interactive advanced solve for x, and that gives me a number which is exact. Turn it into decimals, 24.59. Done the same thing. I could have up here, if I go analysis G-solve, I want an xcalc when that, and I press xe, which selects the blue line because it's flashing. The value I want is 50,000. Go OK, and it tells me that's when t equals 24.59, same as the answer here. Done.